Sir, what do you mean by phase? What do you mean by phase? Okay, once again, will begin with the just now what I discussed. No, okay, this is the plus C. This is minus C. So how the particle in fact is will start from here. Let's assume. Then this is what, okay, once again I'm telling it will retrace path. It's not that it will take a turn, it'll go like this, then mean, then left extreme, again mean. This was the particle described. For our understanding purpose, I'm just giving a diagram like this. So you see that one, I say particle is at a by 2 somewhere here. Then a by 2, it may be moving away from mean position or it may be moving towards mean position. How to differentiate these two position instants of time? Will it be at t equals 0? It will start here. After what time it will be available here? T equal to t by 4. Am I right? T equal to t by 2. 3t by 4. This is one more fundamental thinking a student is asked to make observation. Okay, I get this. So look at this one. T equals it will start. After at t by 4, it will reach right extreme. Then it will move from right extreme to mean. T by 2 it will be at mean. 3t by 4 will be left extreme. Again, at t equal to capital T, one oscillation. This will become one oscillation. This will become one oscillation. So time taken to complete one oscillation, what time period here? Now I say that the particle is at a distance a by 2 and moving away. So this is a condition. No? The particle will be again at a by 2 also when it is moving from right extreme to mean. You can see this. So what about this time, this time? Will they be equal or different time? Definitely, I think uh, this is what the time. And again, it will be at same position after some time. No? So how to differentiate these two positions? I can't just say that at a by 2 moving away, at a by 2 moving towards mean position, at a by 2 moving away. Can you add moving away, moving towards? Any language mathematics is there where with language you can add, subtract, nothing is there. No? So therefore, to I need some sort of a quantity which will define the instantaneous position. I need not to use like particle at time t equal to t1, particle, it is at a distance a by 2 and moving away. And after some time, it will be at a distance a by 2 and moving towards. Instead of this, let me just give a quantity. With that quantity, what pen I should able to tell like where the particle is moving away from mean position or moving towards mean position or the right side of mean position or left side of mean position. For that purpose, I'm introducing the phase. So what is the phase now? How to define phase? What is the phase? Will phase defines the instantaneous position of a particle. Instantaneous at that instant. Okay, at t equal to, suppose this will take 2 seconds to complete one oscillation. Let's assume that it will take 2 seconds to complete one oscillation. At t equal to 0.4 seconds where the particle is. Yes, by phase. If I just select the phase of this much is, I can predict here. No, I brought phase. No, you can ask questions. So what do you mean by phase now? Can you say what is the phase? Phase will be 0. By the time it goes here, the phase will become how much? Will be pi by 2. This will become pi. This will become how much? 3 pi by 2. This will become 2 pi. How you can say? Okay, let me take the circle. Please do understand these are the, you can say the best concept available in SHM. Once you know this phase one, you can manage most of the questions. So what is actually the method? The particle, no? So here it is, what is a zero phase? We'll take it. This as zero phase. 0 degree radians. No, let it be 0. It is this, the phase of this will be pi by 2. The phase of this will be 3 pi by 2. The phase of this will be 2 pi. Okay, now I'm interested in this a by 2. I want the phase at a by 2. When particle is at mean, okay, what do you mean by this? Upper extreme. So we are just what we are doing, we are just bringing all the conditions so that it'll be easy for us to learn things. Huh? This is upper extreme. Am I right? Lower extreme, and this is mean. Okay, the mean. Okay, they said again, don't write mean here. So this horizontal line itself is a mean. Huh? There's a mean portion. Okay, let's do one thing. Particle at a by 2 plus a by 2 means, so shall we put it here? So this distance will be how much it is? This distance will be, okay, this is what amplitude, plus a by 2. So shall we indicate plus a by 2 here? Okay, where the particle is here. It is moving away. So I'll call this is V1. This position as 1. This is 2. I'm very sure that V1 equal to V2. Will I agree? It will have same speed at a by 2, but it's moving opposite. Okay, how to calculate the phase at 1? So here it will be, I'll call the phase as phi 1, we'll write it. What can be the, from mathematics, this should be equal to a only, radius, no, it should be. This is a, so what is this distance? A by 2. What is sine phi 1? What is sine phi 1? So shall we write, pen not responding, I don't know what happened, it is. Pi by 6, what is the phase of this? Will be pi by 6, it will be. Let me write nearby it so that you can focus on that one. And the data is very important. How to calculate phase. So what is the phase of particle at t equals 0? It is here. What is the phase? Will be 0 phase. As it moves, what when the phase will increase? How much it is? Pi by 6 radian at a by 2. How much of phase it will have here? It will have here pi by 2 radian. So what is the phase of particle at 1? Will have, say like a pi by 6, I'll call it. So there's the position of particle 1. Particle at position 1. Now, similarly, when the same particle, it is returning back. So the same graph will take it. A particle now what will happen? Where the particle should be? I'll ask you, I'm making you to look at the graph. Okay, now you carefully tell this one. Let me take it all this. This. Come for this. The particle is, right, there's so many things. Yeah. Come for this one. The where the particle what happen will be here, no? So what is the phase? Now we should define it in this way. So this is a particle to this is the phase of the particle phi 2. What is the distance? This is a by 2. Am I right? After crossing this, it will go to right extreme. Then it will come. No. So the particle what will happen? So will be like this. So when it is here, when particle is moving, so this is like circular motion. Particle bet mean position. By the time it reaches here, its projection will reach on plus a by plus c. Then it starts moving towards. It starts moving in the second quadrant. Then the particle will start moving from right upper extreme or select a right extreme to the mean position. Okay, this is again okay. I'll do correction. Some are asking, sir, is it horizontal or vertical oscillation? Horizontal only. Let me write right extreme, left extreme. Right, left extreme. Right, left extreme. Okay, this one. So can we calculate this angle for this? To calculate that angle, what somehow if you can calculate this theta, problem solved. So what is sine theta? A by 2e. So theta equal to pi by 6. So what is the phase angle? Pi minus theta. So what is the phase of particle at 2 will be 5 pi by 6. So shall we put like the phase, 0 phase, it increases pi by 6 somewhere here, pi by 2, then will further increase, will become how much? 5 pi by 6, pi, 3 pi by 2, then 2 pi. Getting the idea? Listen. So the same graph now will go for showing the phase of a particle. So that will be much easier for you.
Sir?
Yeah.
Sir, here should you not show pi, sir? In
What?
the phase.
5 pi by 6 I show, no? What is there, that one? I'll draw the next diagram. I'll draw the next diagram, then it will be easy for you. No. So this will be plus A.
Sir, left extreme is at 3 pi by 2, sir.
Wait. I'll show it. Give me time. Okay, now this will be 0 phase. Somewhere here at A by 2, how much it is? A by 2, it will be pi by 6. Pi by 2. Again, when particle at A by 2, it will be how much of phase it will have? 5 by 6. So here pi, this will be 3 pi by 2. If you want one more A by 2 or any other thing, if you want, you can show it this one. And this will be 2 pi. Okay, what is the problem now? Tell me.
Sir, I'm saying that left extreme should be at 3 pi by 2, sir.
Okay, I brought it, no.
Sir, in the phase diagram, you drew it at 2 pi. You missed a pi, sir.
Okay. That one, sorry. This one, yeah, fine. This is pi by 2. This should be the pi. This should be the 3 pi by 2. Back it become pi. Okay, the circular, no, it is. Some small correction is there. It should have been like this. Then this will become pi. this will become 2 pi. When it returns back, it will become 2 pi. I think it is understood. So like a protractor, it will be a 0, 0, pi by 2, pi, 3 pi by 2, and this one. So this will be the left extreme will be 3 pi by 2. Yeah. Okay, now I say that particle is having a phase pi by 6. Immediately, can you tell me what do you mean by that? Anybody wants to reply? I say that particle is having a phase of pi by 6. What does it mean? Particle is on the right side of mean position at a distance a by 2 and moving away. I say that the particle is having a phase of 5 pi by 6. What do you mean by that? The particle is at a distance plus a by 2 and moving towards mean position. I think it's very powerful one, no? We are able to express so clearly. Able to understand? So with the help of phase open, I can define anything, not only this, any position I can define it. So now when a particle exudes SHM, so what is a particle? Again, don't think that's some imaginary spring block system only. Go back, see everywhere, your entire numerical discussion should be the background, they should go on. So I have the block now. I'll give it some push. I'll give some velocity, start moving. What happened to phase of this will increase 0. Then it'll become pi by 2, pi, 3 pi by 2, 2 pi. Like that, it'll be continuously, it'll be oscillating. So what is the use of this phase? I can define initial position. I say that the block is having a phase pi by 6. Immediately, what does it mean? The block is at a distance plus a by 2 from mean position and moving away from mean position. If I say 5 pi by 6, it is at plus a by 2 moving towards mean position. So like this, I can able to express now the motion still more very systematically, or you can say better say scientifically. Sir, what is that circular path? It is for our convenient we have brought it to define the angles. So again, the tell me like how the block is moving in circular path, or it is describing to and fro horizontal motion. Please, somebody should reply. Anybody who has understood, please reply it so that I'll feel satisfied that okay, what I'm teaching, somebody is understanding. What is
Sir,
this circle?
we are projecting it as a circle, sir, to and from motion.
Phase diagram.
It's a diagram, that's all. It's
Yes,
a
sir.
diagram. It's a diagram. It's a graphical representation of the motion is what we are doing. How the object is moving spring block system. It is moving horizontally. That's all. Now let's say goodbye to what? The theory. Yesterday, what I discussed, no? Better say goodbye. No, practically, let's jump into the practical situation, spring block system. Okay, how do its phase angle will vary? It's a graphical representation. And in fact, it's going to help us a lot. Don't think that block is moving circular path. Then you have killed total SHM. Better stop reading. After 2 weeks, you again come back to physics class. That much I'll say that. I'm very sure about some of the things. You can't think, you can't bring stupidity in science. I think you do have some program, no? Science of stupidity, that one. When you look at that program, what you feel like. Please do make observation. So without science, what happen? It will become stupidity only. That one, don't say that block is moving in circular path. How block is moving? To and from motion or no? Then what is this, sir? What is this? Graphical representation. How quantities vary. Fine. Don't think that block is moving like this and its projection. No, we don't have anything. Say goodbye to all. Block is moving here. It is just describing to and from motion. Mathematically, what happens? Some quantities to express, I'm taking this graphical representation. Got the idea, no? Okay, there's a use of the phase. So what is the phase? Define the instant position of a particle at any time t. Instantaneous, I'm telling the meaning of that one. At any time t, I can define it very clearly. Okay, now see, what is the advantage of this? I'll ask you, what is the time taken to move from 0 to plus a by 2? The next thing is, so here, so in SHM, we know potential energy, kinetic energy, we know how to write equation also. Next part is how to calculate the time taken